Okay, hello and welcome to my channel. Today we're going to talk about the expectation value of stationary states. So let's start with one definition here is that, well, time-independent observables in a stationary state has its expectation value time independent as well. And you might say that that is quite extra. You don't really need it because, well, your observable is time independent. Then why bother checking the time dependent of its expectation value? But that is completely wrong, as we're gonna see right here. So first, let's start with the Hamiltonian. The expectation value of the Hamiltonian in a stationary state is equal to the expectation value of the Hamiltonian in the state. The stationary state only depends on the x part, because as we have proven before in the last video that, well, when you have this, the time part of it would cancel each other out, and it would only depend on the x part. So this both would equal to energy. So from this we can get two comments, two conclusions. So first is that the expectation value of any operators that is in a stationary state would be time independent. So we would generalize this to a Q operator, an arbitrary operator in psi of x and t would be the expectation value only in psi x. So that would be the generalized form of it. And the next conclusion would be that the superposition of two stationary states won't be stationary. Here we would assume that the two stationary states have different energy. So as you can see that when you have two stationary states that have different energy and you combine them together, it would create an uncertainty in the energy. So there would be spread and it won't be stationary anymore, as that would require to have a stationary state would require the E to be a constant, but when you add them together, there would be an uncertainty. Alright, so that is pretty brief for today. That is it for the expectation values in stationary states. So hope you have a good day. Goodbye.